How are transfer functions used in MIMO control systems? Imagine trying to control a complex machine with many parts moving at once. Each part influences the others, making the control task quite tricky. That's where transfer functions come into play. They are like detailed maps that show how signals flow through a system. In electrical engineering, transfer functions are mathematical tools that describe how an input affects an output in systems that stay the same over time. When systems have only one input and one output, things are simple. But in real-world applications, especially in control systems with multiple inputs and multiple outputs, things get more complicated. In these cases, transfer functions are arranged in a matrix. Think of it as a grid where each row and column represents a specific input and output. Each element in this matrix is a transfer function that shows how one particular input influences one specific output. This matrix helps engineers see the entire picture of how the system behaves. It captures how each input can affect multiple outputs, which is very important because in many systems, the inputs and outputs are interconnected. Using this matrix, engineers can analyze the stability of the system. They can check if the system will respond well or if it might become unstable under certain conditions. They can also see how the system reacts to different signals across all channels at once. This is especially useful because a change in one input might cause unexpected effects on several outputs. Designing controllers becomes easier with transfer function matrices. Engineers can develop strategies to make the system respond faster, stay stable, or reject disturbances. They can even create control methods that reduce the effects of cross-coupling, which is when one input unintentionally influences multiple outputs. Transfer functions also allow for simulation of how the system will respond to different inputs before actually building or programming it. This helps save time and resources. For example, in wireless communication systems that use multiple antennas, transfer functions model how signals travel and interact. This helps optimize data flow and improve signal quality. In summary, transfer functions in multiple input, multiple output control systems serve as a detailed blueprint. They help in understanding, analyzing, and designing complex systems where many signals interact at once. They turn a complicated web of interactions into a manageable mathematical form, making control and optimization possible.